Okay, here we go. Today we're going to talk about something called synthetic division, but we're going to start with something that you're already familiar with, which is polynomial long division. So how does this work? Well, we take the polynomial from the numerator and we rewrite it, 5x cubed minus 6x squared minus 28x minus 2. And we're going to divide that by x plus 2. So we bring that binomial right out in front. We can use a sort of divisor bar here thing if we want to. Works out pretty well generally. So here what we really want to ask ourselves is the product of x and what will give us this first term 5x cubed? And the answer is 5x squared, right? If we multiply 5x squared and x, we're going to get 5x cubed. But the trick here is to also multiply 5x squared by 2. Because we're multiplying 5x squared by the entire binomial x plus 2. So what we get here, 5x squared times 2 is 10x squared. Now there's another little trick or important thing to consider when you're doing polynomial long division, and that is we need to subtract this entire binomial, 5x cubed plus 10x squared. Well, the way that works is we're going to have 5x cubed minus 5x cubed, which is essentially 0. And then we're going to have negative 6x squared minus 10x squared, which is negative 16x squared. That's where I see most students sort of go wrong with polynomial long division. And the next step is to move down the next term, which is negative 28x. Okay, so here we start the whole process over again. And we say the product of x and what gives us negative 16x squared. I'm going to erase this 0 because I usually don't write that there. It's a little bit awkward to have that there. So the product of x and what is negative 16x squared? And the answer is negative 16x, right? So if we multiply negative 16x times this binomial x plus 2 sitting here over to the left, the first term is going to be negative 16x squared, just like it should be. The second term is going to be now negative 32x. But remember, we're subtracting this entire binomial. So negative 16x squared minus negative 16x squared is essentially negative 16x squared plus 16x squared, which of course is 0, that's great. But look what happens next. We have negative 28x minus negative 32x, which is the same as negative 28x plus 32x, which is 4x, okay? One more term that needs to be brought down here, which is the negative 2. We bring that straight down, and we do this once more. The product of x and what is 4x? The answer is 4. The product of 4 and x plus 2 is 4x plus 8, but remember, we subtract that entire binomial. 4x minus 4x is 0. Negative 2 minus 8 is negative 10. So we end up with a remainder of negative 10. And back in the good old days, we just drew a big capital R and with the negative 10 next to it for remainder, but we don't do that anymore. We abandoned that a while ago. And so what we do now instead is we say plus, and we put this remainder negative 10 over the binomial x plus 2. And there you have it. That's polynomial long division. The answer would be 5x squared minus 16x plus 4 plus negative 10 over x plus 2. Okay? The next thing we're going to do is I'm going to introduce you to something called synthetic division. But notice, it's the exact same problem. It's 5x cubed minus 6x squared minus 28x minus 2 divided by x plus 2. Well, we're going to simplify things a little bit here. Instead of writing the entire polynomial that's in the numerator, we're just going to use the coefficients. So we're going to use 5, we're going to use negative 6, we're going to use negative 28, and we're going to use negative 2. So already we've simplified things quite a bit here. And we can still draw the same little, I don't even know what you call that. I usually call it a divisor box or something. And instead of using the actual binomial in the denominator, we're just going to use the 0, okay, the corresponding 0. And what I mean by that is if we take that binomial and we set it equal to 0, we end up with x equals negative 2. Negative 2 is what we use for synthetic division, okay? So rather than putting x plus 2 outside of this divisor box, we put negative 2. Now watch what happens. With synthetic division, it's far easier than polynomial long division. The first step is always to bring down the first term. So I'm going to bring down 5, and then I'm going to multiply. Negative 2 times 5 is negative 10. Now with synthetic division, we don't have to worry about subtracting negatives and sort of all that sort of confusion with distributing the negative sign. You just add, and negative 6 minus 10 is negative 16, okay? Now we multiply again. Negative 2 times negative 16 is positive 32. Does this look familiar? It should. 32 minus 28 is 4, and finally we end up with negative 2 times 4, which is negative 8, and then here's the remainder from the last problem. So you see, we end up with the exact same answer. This 5 here actually represents 5x squared, this negative 16 represents negative 16x, and this 4 actually represents 4, the constant. Of course, negative 10 is the remainder, so we do the same thing. We put that remainder over the binomial, and there we have it, right? We have the same answer that we obtained using polynomial long division, right? And that answer's up here. I never boxed it, but I will now. Exact same result, but you can see far easier to use synthetic division. It's just a lot more streamlined, and there's actually a lot less chance of making mistakes when you use synthetic division. So that's one of the things I'm going to want you to do on tonight's homework. Here are a couple things related to synthetic division. It's really kind of cool, okay? And this is called the remainder theorem. It says if a polynomial is divided by x minus k, then the remainder is equal to f of k. Well, that's interesting. Let's go back here for a second. We divided a polynomial by x plus 2, right? So perhaps this remainder here, negative 10, maybe that's f of negative 2. That's the remainder. That's what the remainder theorem tells us. Is it possible that that's f of negative 2? Well, let's find out. Let's take this polynomial and let's substitute negative 2 for x, the top polynomial from the numerator. 6 times negative 2 squared minus 28, times negative 2. Is it possible this actually works? Let's see here. Let's see what happens. So this is how we find f of negative 2 traditionally, right? We just substitute x with negative 2. Negative 2 cubed is negative 8, and 5 times negative 8 is negative 40, okay? Negative 2 squared is 4, and 4 times negative 6 is negative 24. Negative 28 times 2 is positive 56, and then we have a negative 2 over there. Let's see what happens here. This is negative 64 plus 54, oh my gosh, negative 10. It turns out the remainder theorem really works. If you want to find f of negative 2, rather than using direct substitution, which is what this is called, you can actually use synthetic division with negative 2 and the polynomial, and the remainder will be f of negative 2. So we'll do that in just a moment, but what a cool result of synthetic division. Now, if we think about that for a moment, let's go back here for a moment. What if that remainder hadn't been negative 10? What if the remainder was 0? Okay? If the remainder was 0, that means this bottom polynomial, x plus 2, was actually a factor of the original polynomial. Okay? It would have been a factor of the original polynomial. And therefore, k, which in this case was negative 2, ends up being a 0 of the function. Okay? And what that means is at that value of x, if we substitute that value of x into the original equation, y would be equal to 0, which is pretty interesting. Okay, we'll talk about that in a moment too. So we've got some other information here for you. It says the real number zeros are the x-intercepts. Okay, and that means if we were to graph the function, the zeros are the places where the actual graph crosses the x-axis. Okay? And then just we're letting you know that a 0, there's another name for 0, which is a root, okay? And we can also call it a solution of the equation. So all of this good information. Let's continue here. This says use synthetic division to determine if f